This is Go Math Lesson 13.6. It's on statistics and probability. The standard is 6.sp.3. The title is Apply Measures of Center and Variability. The essential question is, what do measures of center and variability indicate about a data set? So Julia is collecting data on her favorite sports teams for a report. The table shows the median and the interquartile range of the heights of the players on her favorite baseball and basketball teams. How do the heights of the two teams compare? Compare the medians and the interquartile ranges of the two teams. So we have the baseball team heights, the median is 70, and the interquartile range is 6 inches. And then the basketball team heights, the median is 78 inches. And the interquartile range is 4 inches. So the median of the basketball players' heights is 8 inches greater than the median of the baseball players' heights. The interquartile range. The interquartile range of the baseball team is greater than the interquartile range of the basketball team. So the heights of the baseball players vary more than the heights of the basketball team. So the basketball team is taller and there's less variability within their group. It's only 4 inches where it's 6. So the players on the basketball team are typically taller than the players on the baseball team. And the heights of the baseball team vary more than those of the basketball team. Number 1, Julia randomly picks one player from the basketball team and one player from the baseball team. Given data in the table, can you say that the basketball player will definitely be taller than the baseball player? Explain your reasoning. So no, we cannot be certain. The median height of the basketball players is greater than the median height of the baseball players, but that does not mean that every basketball player is taller than every baseball player. There could be one really tall baseball player on the team. Okay, example. Kamira and Joey sold t-shirts during lunch to raise money for a charity. The table shows the number of t-shirts each student sold each day for 2 weeks. Find the mean and range of each data set and use these measures to compare the data. Step 1, find the mean of each data set. And so remember, to find the mean, you have to add everything up and divide by however many data points are in the table. So I have 5, 1, 2, 1, 3, 3, 1, 4, 5, 5. And it's over 2 weeks, but that's 10 days because it's during lunch. So divide by 10. So 5, 10, 15, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 divided by 10, which is 3. And then Joey has 0, 1, 2, 13, 2, 1, 3, 4, 4, 0, 4, 4, 0, and it's 10 days because it's 2 weeks during lunch. So I'm going to add these all up. So 13, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Divided by 10 is 3. So their mean is the same. You have to still divide by 10 even though there's 0 because that is a data point because they didn't sell anything on those days, but it counts. 0 is a number. So it says error alert. Make sure you include zeros when you count the total number of data values. Step 2, find the range of each data set. So Kamira, the largest number in her set was 5. And the smallest number in her set was 1. So I'm going to go 5 minus 1, which is 4. And then for Joey, his range, the highest number was 13. and his lowest number was 0. So 13 minus 0 is 13. Step 3, compare the mean and the range. So the mean of Joey's cells is the same as the mean of Chimera's cells. The range of Joey's cells is greater than the range of Chimera's cells. So the typical number of shirts Joey sold each day was the same as the typical number of shirts Chimera sold. However, since the range of Joey's data was greater than Chimera's, the number of shirts Joey sold varied more from day to day than the number of shirts that Chimera sold. Question 2. Which measure of center would better describe Joey's data set? Explain. So this is not a very good indication, the mean, because he has so much variability in his set, because he has everything from 0 to 13, which our range showed. So the measure of center that would better describe his data would be the median. So the median would be 2, which is really close to the number of t-shirts that Joey sold on all but one day, which was the day when he sold 13. I'm going to do a couple more problems for you. Zoe collected data on the number of points her favorite basketball players scored in several games. Use the information in the table to compare the data. So we have player 1 and their mean is 24 and their inner quartile range is 8. And then player 2, their mean is 33 and their inner quartile range is 16. So the mean of player 1's points is less than the mean of player 2's points. The inner quartile range of player 1's points is less than the inner quartile range of player 2's points. So player 2 typically scores more points than player 1, but player 2 scores typically vary more than player 1's scores. So this person scores less but is consistently scoring that many. This one might have, less in one game and more in another game, so more variability. Okay, question 2. Mark collected data on the weights of puppies at 2 animal shelters. Find the median and the range of each data set and use these measures to compare the data. So I have shelter A and shelter B, and it wants me to find the median and the range. So I'm going to put the numbers in order from least to greatest because I need to do that when I'm looking at the median. So I'm going to put shelter A, and then my lowest number in this is a 5. And then I have 3 7s, and then I have 10 and 12 and 15. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. My number in the middle is a 7. So my median for shelter A is a 7. And then to find my range, I'm going to subtract my my smallest from my largest. So it's 15 minus 5, which is 10. So my range for shelter A is 10. My median is 7. Then shelter B, I'm going to put my data in order from least to greatest. So 4 is my least value. And then I have 1, 2 5s. And then I have 2 11s. And then a 13 and a 15. So 1, 2, 3, 4, 5, 6, 7. My number in the middle is 11, so my median is 11. And then to find my range, I'm going to subtract my smallest from my largest value. So it's going to be 15 minus 4, which is 11. So as I said before, the median of shelter A is 7 pounds, and the range is 10 pounds. Shelter B, the median is 11 pounds, and the range is 11 pounds. So there's about the same variation within the two sets of data, because one's 10 and one's 11, but the typical weight of a puppy in shelter B is greater than the typical weight of a puppy in shelter A. So if you have any questions, leave them on the classroom. Thank you.